We have all seen AI avatars. They look cool, but usually they suffer from two massive problems. One, they treat you like a total stranger every time you come back. You close the tab and they forget who you are.
Wait a minute, who are you?
And two, and even bigger, is that they're painfully slow. You say hello and then there's an endless wait just to get the first response. So in this video, I'm going to show you how to build a real-time AI assistant. This isn't just a chatbot, it's an interactive avatar powered by a human-like memory using knowledge graphs. I have open sourced the entire code for this, which I'm going to share with you. And the best part is we are achieving sub-second latency. I'm talking about 100 to 200 milliseconds from the moment you ask the question to the moment AI understands it, fetch the relevant context and responds back. So without any further ado, let me show you a live demo of how it actually works. So currently you are looking at the Streamlit application that we created, and this is going to be your interface to interact with the avatar. And I have grounded the knowledge of this avatar to our three books: the AI Agents book, the MCP book, and the Data Science Archive book. So let's get back to the application. So we'll start by initializing a user session. We'll wait for the avatar to come up.
Hello, how can I help you today? What would you like to learn about ML and AI engineering? I have access to the entire data science archive and books on MCP and AI agents.
I want to build an integration for Cloud Desktop and Cursor using a shared memory via MCP. How do I do it?
Based on the information available, you can build an integration between Cloud Desktop and Cursor using shared memory via MCP by following these key approaches. Use Graphity MCP as the shared memory layer. Deploy Graphity MCP via Docker Compose with a local Neo4j instance which connects to both Cursor and Cloud Desktop applications to enable shared context between them. The MCP server acts as a bridge, with Graphity MCP serving as the common memory layer that both applications can access, making it a scalable solution for cross-platform AI agent communication.
Okay, so this was not a random answer. I'll show you. In our MCP book, we have a chapter which is dedicated on building a memory layer for Cloud Desktop and Cursor, so that even if you're switching between these two apps, you're not switching context. So let me show you that chapter. Alright, so this is the chapter we have. MCP powered shared memory for Cloud Desktop and Cursor. And as you remember, the solution that the avatar suggested was to use JEP as a shared memory layer, which is exactly what we have done here as well, right? So just wanted to show you that it's not just making up the answer. It is actually retrieving everything from our knowledge base and then providing you the answer. And one more thing that I wanted to show you is how fast it is. So if I come back here and look at the logs from our backend, so you can see this is the query that we asked. I want to build an integration for Cloud Desktop and Cursor using a shared memory via MCP. And you can see the latency as well. We are able to retrieve this context from a vast knowledge base across three books in just fraction of a second. Okay, so now that you've seen the demo, and before we jump into the code, let's take a moment to understand what's actually happening under the hood by looking at this diagram. It starts here on the front end with the Streamlit application. When the user opens the app, we initialize a session and immediately we contact ZAP. We aren't just creating a chat session, we are retrieving a specific user and a thread, and this becomes our persistent memory line. And at the same time, we request a token from the enum service. This wakes up our AI avatar that you can see here, and it is ready to listen to our queries. Alright, so next is our Fast API backend. So this is basically the brain of our application, and it is powered by JEP's knowledge graph. So while most RAG apps just rely on similarity search and all, in this case, we are actually using a human-like memory. The backend searches the knowledge graph, pulls the context from JEP's memory. This means it understands the relationship between data and not just the naive cosine similarity. Now we take this rich context that we fetch from our knowledge graph to an LLM, and then it creates a coherent response. Now again, the backend receives this response and streams it back to the AI avatar. And the AI avatar then finally speaks back to the user, and the user hears the final response. And while all of this is happening in the background, everything is being saved back to the JEP thread, updating the knowledge graph for the next interaction so that the avatar never forgets about you and it gives you a more personalized experience. So now that you've seen the demo and understood how everything is working under the hood, let me give you a quick code walkthrough and how to actually build this yourself. And I'll also show you where you can find all the codes and everything that you need to reproduce this work. So mainly we have two files. One is our Streamlit application, and the code for this is inside the app.py. And then we have created a fast API backend inside backend.py. So it's the backend that integrates JEP's knowledge graph, your LLM, and the AI avatar service. So all the code can be found here. So the first thing that you need to do is to start this backend service. Once it is up and running, as you can see here, you can go to another tab and you can start your Streamlit application. Right? So from here, you have already seen like how you can interact and work with it. But I'll also quickly show you some of the important files and it will help you to, let's say, modify this according to your need, or maybe if you want to, reproduce all of this work. So we have already seen the app.py and the backend.py. I have put together all the important scripts inside services.py. So mainly we have three main services. One is Anum services. So this is basically the provider of your AI avatar that you saw in the demo. And then this is the core of our application, which is the depth service. So in here we have all the code for creating a knowledge graph, ingesting knowledge into it, and how you can retrieve from it. And then we have this LLM service. So in this case, I'm using Minimax M2 as the LLM, and in here we have provided all the code how you can send a request to this and get response back. So the entire code is fully modular. You can modify individual services. I mean, I have used Enum just for the sake of using it, but you can always replace it with some other service as well. Same goes for the LM service, and same goes for the JEP service that we created. Everything is fully modular. You can easily modify these things according to your need. But overall, the interface is anyways going to remain same. And finally, I have also created a really nice notebook for you. So basically, this gives you a procedural understanding of the entire flow. So if you try to reproduce this work, I encourage you to first test it out by running the application, and then run this notebook that will give you a concrete understanding of all the nuts and bolts of this application. I have shared the entire code on my GitHub repository. I'll share the link for the same as well. And in the README, you can find all the instruction and the dependencies and everything that you need. And if you follow this guide step by step, you can easily reproduce everything that I've just shown you. And I highly encourage you to check out JEP's Graphity. And this is something that is completely open source. You can self-host the entire thing. I have shared a lot of tutorial on the same in past. Just let me know in the comments. I'll share that with you. And although in this case, we have used their cloud offering, but you can easily use this and self-host it as well. So feel free to do that. So with that, we come to the end of this video. And if you made it this far, make sure that you like this video and support my work. As always, I'll see you in the next one.